All right, how's everybody doing out there today in Calculus Land? Today's video lesson is going to be brought to you by Mr. Muscarella as we take a look at integration technique called partial fractions. In some textbooks, they'll refer to this as partial fraction decomposition. And basically, we're using this technique anytime we've got to integrate rational functions. Now, why do we need this type of technique? I mean, we already know how to integrate, so what's this all about? Well, let's journey back to the old days of algebra. Come with me as we take this journey to add these two rational fractions, 3 over x plus 1 plus 2 over x minus 5. Now this is going to be pretty elementary for a calculus level student, but there was a time when you actually struggled with this, maybe even for a brief moment. So the first fraction is going to change into 3 times the quantity x minus 5 over x plus 1 times x minus 5, because remember, you got to get at the common denominator. And our second fraction is going to change to 2 times the quantity x plus 1 over x plus 1 again, and then x minus 5. So this is these two fractions, the sum of them added together, getting our common denominator. Now when we clean this up, and again, for a calculus student, this is going to be pretty straightforward stuff. You have 3x minus 15 for the first fraction, plus, I'm going to write this together, 2x plus 2 in the second fraction, all of that over. Now, we'll go ahead and do this the long way just to take you back and reminisce. You'd have x squared minus 5x plus 1 minus 5 in the denominator. Cleaning all of that up, you would end up with 5x minus 13, all of that over x squared minus 4x, and then minus 5. Oops, I forgot my 1x right there. So this fraction, 3 over x plus 1, plus the other fraction, 2 over x minus 5. If we were to find the sum of them, we would end up with 5x minus 13 over x squared minus 4x plus 5. But what if we had to integrate 5x plus 13, or 5x minus 13 over x squared minus 4x minus 5? We can't do that using the techniques we've learned so far. So what we're going to need to do is do a technique called partial fraction decomposition. And in doing that, we're actually going to be breaking this down and getting this form back into this piece right here. Now the 3 in the numerator and the 2 in the numerator, those pieces are going to come later. But right now, we're just going to kind of leave those as constants as we play along with this. In order to do this, we're going to have to actually know how to factor. So that's the first thing that we want to do, is we're going to take these and we're going to divide the fractions up so that we can break them down. Now here we have 5 over x squared minus 10x, for example A. So that's just going to be 5. If we were to factor that, we're going to have x squared, or not x squared, the x squared minus 10x is going to factor into x times the quantity x minus 10. Now in breaking this down, we're going to have some constant over the first term, over the x, plus some other constant over the x minus 10 piece. And that's it. Those actual constants, a and b, we'll figure out how to get to those things later. But right now, I just want you to practice and understand how to break the fraction apart into its partial fractions. This 2x minus 3 over x cubed minus 10x, this one's going to be a little bit different. Because when you do this one, 2x minus 3 over x cubed minus 10x, you're going to be able to factor out an x, and then you're going to have x squared plus 10. So the first term, you're going to have some constant over the x. Now our second term, since that's going to be over x squared plus 10, now the numerator is always going to be 1 degree less than the denominator. So the denominator here in this case is x squared. Now x squared is going to be a quadratic. 1 degree less than that is going to be x, or a linear function. And a linear function is going to take this form, bx plus c. So that would go in the numerator for this one. Now, let's take a look at example C. C, we'd have the x minus 1 over x squared. This time we're going to be able to pull out, and then we're going to have just x plus 1 as our remaining factor. So again, this one is going to be a little bit different, and we're going to have a over x plus b over x squared. Now all of that, those two pieces are going to give you are going to be the possible factors for this x squared. Now if we had x cubed, if we were to factor out an x cubed instead, then we would end up with a over x plus b over x squared plus c over x cubed, if instead of x squared that was an x cubed. But since we just have x squared, we're going to factor out just a over x plus b over x squared. Now that's how you break that part down. And then the other piece is going to be that x plus 1 in the denominator. But since that's linear, x plus 1 is a linear function. It's just a line with a slope of 1, y-intercept of 1. 1 degree less than a linear function is just a constant. So that's why here you're just going to have c. Now in the AP exam, you're only going to have to integrate partial fractions that are like type A. They're only going to be linear. The denominators are going to be linear in nature. You're not going to have to do anything like B or C. So more on that later, finding out the actual values of your constants in your numerator. But right now I just wanted to practice how to get the form of the partial fraction decomposition before we actually do the integration piece. Alright, so that's it for this example. Thank you guys for watching. Have a great day and peace out.